All right, continuing in Chapter 7, this is example 4 from section 7.1. It says the total cholesterol for males ages 20 to 29 years old is approximately normally distributed. It tells us that we can draw this bell curve with a mean of 180 and a standard deviation of 36.2. We want to determine the probability or the chance that a randomly selected male in that age range has a cholesterol level above 200. So this is what I call the target. Target is above 200. So the first keyword word we see is normally distributed. If that says uniform, you draw a rectangle. If it says normally, we draw a bell curve. So it says to draw a curve to represent this data, labeling 3 standard deviations out in both directions. So you want to draw a nice sized curve, not too small so you can really see it all. On your test, even though it's a computer test, I do want you to draw the curve on your scratch paper and label it so that if it misgrades the problem or if you miscalculate something, I can go back to your scratch paper and see your work. So drawing the curve is always a good idea. The mean goes in the middle, 180. We're going to go 3 standard deviations out in both directions. And that gives us 216.2. I'm going to kind of round these off, 252, 288. Going backwards is about 143, 107, and I'm just again rounding in 71.4. So what you want to do is put your mean in the middle. It's okay to round the standard deviation just to kind of give you an eyeball of where those marks are. And then you want to shade the area of interest. This is very important. Shade the area of interest. So we're looking at cholesterol levels above 200. 200, and it doesn't have to be perfectly to scale, but 200 falls somewhere between the 180 and the 216. So 200 is somewhere in there. And it says above 200. So we're going to shade the area of the curve that represents above 200. So again, on your homework problems, on your test problems, you want to draw your curve a little bigger than I did so you have plenty of space. Mark your target value, and if you're shading to the left or to the right of that curve, of that mark. So above 200 would be to the right of 200. And it says suppose the area of that shaded piece, so the part we just shaded, is 0.2903. Remember, the whole curve adds to 1, so this is 0.2903. That means that there is a 29%, so I'm rounding this off to about 29% chance of a male ages 20 to 29 having cholesterol. I always spell cholesterol wrong. The O goes there. Sorry about that. Cholesterol above 200. Sorry about the spelling mistake there. So there's a 29% chance. So this number, this area, is a percentage of, it's a chance of your selected 20 to 29-year-old male with a cholesterol level above 200. So whatever percentage you get, it answers the question that's always at the end of the problem. So that's a percentage chance of this condition being true, having that cholesterol above 200. So we're going to actually learn how to get that number. Right now the book just wants you to practice what that means and how to set it up. We're going to learn how to get the 0.2903 in section 7.2. Page 4 of your notes are some extra examples. There's an extra example of a uniform distribution and an extra example of just kind of setting up that bell curve and understanding what these numbers mean. So those are both good practice. They should be pretty easy. If you want the answers again, you can just email me individually and I can send you those answers. I do want to make one note about these problems. On your homework and test, it's not going to say uniform distribution like that. So the problem will start and you have to find the words, find those key words. So you need to find the word uniform in the problem to know how to set it up. It's not going to tell you at the beginning what kind of problem it is. So it's very important to look for those key words. But you can try those too, and I can send you the answers if you'd like me to. Just email me individually. All right, so I want to get into how to actually get these different probabilities. So we know how to set it up, but how do we get those answers? There are two methods I'm going to show you. Either one is fine. The calculator is a little bit more reliable and a little faster, but I want to show you how these charts work so that you can know what the calculator is doing. So we're going to use the chart, which is kind of the by hand method, and then I'll show you how to use the calculator. So I have two examples here. We're going to do both examples using the chart, and then we're going to do both examples again using the calculator. Alright, so to use the chart, the first thing I want you to do every time is draw, label, and shade your normal curve, just like we practiced. Then you're going to find the z-score of the value. The z-score formula is back in chapter 3, but they also repeat it here in chapter 7 of your formula book. There's your z-score again. So remember, z is x minus mu over sigma, and you have to subtract before you divide. Once you find your z-score of the value, you look up your z-score using the table. This table 5 is in the back of your formula book on page 6. So table 5 is page 6 of your formula book. Page 6. It says table 5, standard normal distribution. And I'll show you how to read this here in just a few minutes. And then sometimes you'll have to subtract this value from 1 for any greater than probabilities. We did that when we had binomial CDF back in chapter 6, where we had to subtract from 1. So if you choose to work these by hand and use the chart, you always have to subtract from 1 if you're looking at a greater than probability. When we learn the calculator method, you no longer have to do that. So just make special notes and decide which technique works best for you. Alright, so the first example, IQ scores can be modeled by a normal distribution with a mean of 100 and a standard deviation of 15. What is the probability that someone has an IQ of over 120? So the first thing we want to do is draw our curve centered at the mean of 100, standard deviation of 15. So we're going to go 15 out once, twice, and 3 times, and back once, twice, and 3 times. So that's drawing and labeling, and then it's very important to shade the region of interest. So we're looking at over 120. So 120 is somewhere in there, and we're looking at over 120. So you really want to have that shaded. We're visual creatures, and so having that shaded is a good check to know what kind of answer you should be getting. The next step for using the chart is to get the z-score. The z-score is 120, that's your x value, minus your mean of 100, divided by your standard deviation of 15. You want to subtract before you divide, so 120 minus 100 is 20, divided by 15. Gives me a z-score of 1.3 repeating. And we're going to round to the nearest 100. So you always round to 2 decimals every time. So that's 1.33. So now we're going to look this up in the chart, and I'm going to show you how this works with the chart. So we need to look up the z-score. So let's get to page 6 of your formula book. I don't think the camera will let me zoom in, so hopefully you can see these numbers okay. You should see the letter Z up here at the top of the table. You've got negative 3.4. It gets less and less negative, closer to 0. Right in the middle, you have 0. That's the center of your curve here. That's your 0. And then it continues into the positive all the way up to positive 3.4. Across the top are the hundredths place. So this is the ones place and the tens place, and then that second decimal is across the top. So our z-score was 1.33, and it's positive, so I'm going to go to positive 1.3, and you might want a ruler for this. 1.3, and then I'm going to go to 3 across the top and down, so 3 and down, and you should see 0.9082. And that's lining up at that hundredths place of 3. Oh, I already forgot the number, 0.9082. Alright, and it says you might have to subtract that value from 1 for greater than probabilities. So if you notice on the little picture at the top of page 6, it shades it to the left. That's telling you that all of these probabilities are to the left. Kind of like your calculator at the binomial CDF always goes from 0. So because it's to the left and we want what's shaded to the right of 120, we have to do 1 minus that number, and that is our answer. So 1 minus 0.9082, 0.0918. So this number is about 90 to 91%. And using our knowledge of how a bell curve works, we know that this little area is not 91% of the curve. 91% of the curve would be the majority of the curve. So if you get an answer that's more than 50%, but you didn't shade more than 50% of the curve, that's an indication that you might need to subtract from 1, or you just did something wrong. So use your shading in your drawing to kind of see if your answer is reasonable or not. If you shaded less than half the curve, your answer should be less than half, less than 0.5. All right, let's look at the second example. This is the pediatrician example from before. So she obtains the heights of 200 3-year-old females. The heights are approximately normally distributed with a mean of 38.72 and a standard deviation of 3.17. Same statistics from before. Determine the proportion of 3-year-old females that are less than 35 inches tall. So we're going to draw our little curve here. Now on your drawing, it's okay to round. So it's okay to round when you're just drawing yourself a little sketch. So I'm going to call that 39, and I'm going to call that 3. And that's just to make myself a nice little curve. So I'm going to count by 3s here. You're just trying to get a quick visual of where your data fall. So I'm going to call that 42, 45, 48. I'm just kind of eyeballing, approximating 36, 33, and 30. So it's okay to round in your drawing. It's not okay to round anywhere else, but it's okay to round in your drawing. Now our target range is less than 35 inches tall. So 35 falls somewhere in here, and it says less than 35. So we're going to shade the less than part of the curve. So we know our answer is to the left of 35. Looks like we shaded less than half the curve. And that gives us some idea of where our numbers should be. So let's get our z-score. This is x, sigma, and mu. No rounding here. So we need 35 minus 38.72 divided by 3.17. So no rounding there. We're going to do 35 minus 38.72. It's okay to get a negative number for z-score and then divide by 3.17. A negative z-score just tells us we're to the left of the mean, and that's okay. Now we can round to 2 decimal places, so that would be negative 1.17. Now we can look that up in the chart. So negative 1.1 and then over to 7. So I'm going to go to negative 1.1 here and then over to the 0.07 column. So negative 1.17. Looks like it's 0.1210. So 0.1210. Now we have to think about, do I need to subtract that from 1? It says we only have to do that for greater than probabilities. This was a less than probability to the left, so we don't have to do that. Our answer is just 0.1210, which should fit our shading of less than half of the curve. So the drawing, labeling, and shading is very important to back up the rest of your work and to double check if your final proportion makes sense or your probability makes sense. How we're doing on time. All right. So I'm going to show you the same thing using the calculator. So the steps for using the calculator are a little simpler if you're comfortable with your graphing calculator. I still want you to draw, label, and shade your curve. That's important to me because it gives you, again, that good visual. Using your calculator, you're going to go to second vars. You're going to choose this time normal CDF instead of binomial CDF. And we put in 4 arguments into normal CDF. The first one is called the lower bound. The second one is called the upper bound. The third argument is the mean. And the fourth argument is the standard deviation. And for this, you do not have to subtract from 1. If you set this up according to the problem, the lower and upper bound correctly, you do not have to subtract from 1. So this is a shorter process if you can remember the arguments for the calculator, which can sometimes be a little confusing. All right. So let's look at that first example. Same example, but this time with the calculator. So I still want you to draw, label, and shade your curve. The mean for the IQ scores was 100. Standard deviation of 15. And you can copy from the previous page if you want to. 115, 130, 145, 85, 70, and 55. Our target was over 120. So there's about 120. Over 120 is here. The thing to remember is what we talked about before, that this goes all the way to positive infinity. So even though we know it ends somewhere in there, we don't exactly know where the highest IQ is. So we just go all the way to the extreme of positive infinity. To put positive infinity in the calculator, you do 10 to the 99th power. That's enough zeros to call it infinity. 10 to the 99th power. So the way normal CDF works is lower bound, which is the left, and upper bound, which is the right. And it's based on your shaded region. So our shaded region is here to here. So this is left to right. Again, this graphic is so important to make sure you're entering in the calculator correctly. So the leftmost point of my shaded region is 120. And the right bound, the upper bound, is infinity. So we're going to put 10 to the 99th power. And I'll show you how to put that in just a minute. And then your next argument is the mean, which is 100, and the standard deviation, which is 15. So it's left, right, mean, standard deviation. Every time, same order. Left, right, mean, standard deviation. So in the calculator, if you have a newer calculator, second vars, it's the second option, normal CDF. If you have an older calculator, second vars, it's still the second option, normal CDF. On the older calculator, you have to remember left, right, mean, standard deviation. On the newer calculator, it kind of spoils you, lower, upper, mean, standard deviation. So our left is 120. Older calculator, you put a comma. Newer calculator, go down. Upper is infinity, 10 to the 99th power, 10 to the 99th power, comma, or down. Our mean is 100, 100. And our standard deviation is 15, 15. Close parentheses or choose paste. So again, older calculator, you have to remember that order, which you'll get used to. You do plenty of these problems. Newer calculator, it kind of helps you out. We're going to go to paste, hit enter, and that gives us the number we would have gotten from the chart. So the chart is stored in these calculators. You just have to know how to call on it appropriately. It knows if it needs to subtract from 1 because of the order of the lower and the upper bound. So it has this chart stored in it, and it knows whether or not to subtract from 1 based on how you put in your bounds. And so we get the same answer, 0.0912. Go ahead and try the same thing with example 1. I think the video is going to cut me off, so I'm going to stop and start the next video segment.